We're at a really critical moment in digital security. The very systems that protect all of our data today, well, they won't protect us tomorrow.
So you might be asking, what's the big rush? It all boils down to one. If a totally new kind of computer could just shatter today's encryption, exposing decades of our most important secrets. This isn't science fiction anymore. It's the very real threat posed by large-scale quantum computing.
So first, let's really get a handle on the problem. It's like a ticking clock, and that clock is the quantum threat.
Think about our security. Algorithms like X25519, which is a real workhorse of modern encryption, are practically unbreakable. But the whole game changes once quantum computers get powerful enough. That same bulletproof algorithm suddenly becomes fragile, totally breakable by a quantum machine.
And the specific weapon that makes this all possible? It's called Shor's algorithm. What's so wild about it is that it's not a brute force attack. It's this incredibly clever quantum algorithm that's specifically designed to solve the exact kind of math problems our current encryption is built on. It doesn't just guess the key, it elegantly picks the lock on our entire digital world.
And this leads to a pretty chilling scenario, something called a harvest, recording all of our encrypted traffic. So you see, the clock is already ticking on the secrets.
So how do we build that bridge to a quantum-safe future? Turns out there's this fascinating hybrid approach. We already use X25519 with a new powerhouse, ML. Let's break down how this whole thing keeps us safe, but for decades to come.
There's a really clever plan to fight back, and that brings us to our solution. The core idea here is simple but powerful.
Two locks are better than one. Instead of just ripping out our current trusted systems that work perfectly fine, it's all about adding a brand new layer of protection on top.
This whole strategy is called hybrid cryptography. It's a really powerful method that combines a trusted classical algorithm with a new quantum-resistant one. This creates what we call defense in depth. It means that even if a future quantum computer breaks that first lock, the second one holds strong, keeping your data completely secure.
It's like a built-in safety net.
The first one is X25519, the fast, efficient, super trusted standard we use all across the internet today. And the second one is MKM768. This is a brand new algorithm, standardized by NIST, that's the US National Institute of Standards and Technology, and it was specifically designed from the ground up to resist attacks from both classical and quantum computers. But how do they actually team up to protect a connection in the real world? This brings us to the hybrid handshake, and it's this surprisingly elegant four-step process. First, your device and the server each generate two key pairs, quantum resistant. Step 2, they swap their public keys. Easy enough. They each use that info to calculate two separate, independent shared secrets. Get fed into something called a keys derivation function. Think of it like a cryptographic blender. It mixes them together to create one single ultra-strong session key. To break it, an attacker would have to defeat both algorithms, not one or the other. But you're probably wondering, what about the real world? And maybe more importantly, the performance. Is this going to slow everything down? And this right here is where the news is really good. The baseline on the left is the speed for a standard X25519 handshake. The second bar shows the hybrid approach. And look at that, the increase is tiny. We're talking about just a few milliseconds. It's an incredibly small price to pay for literally future-proofing our security. Of course, there is a trade-off, and that's key size. A classical X25519 key is a teeny tiny 32 bytes. The new quantum-resistant ML-Chem key is a bit bigger, around 1.2 kilobytes. But honestly, in the context of modern internet speeds and networks, that increase is totally manageable. You get far outweighs this tiny increase in data. So let's zoom out. What does this all mean for the big picture? Building a much more resilient internet for the future. Critical sectors are already demanding and implementing quantum-safe security. We're talking about government communications, the entire global financial system, our sensitive healthcare data, and all the critical infrastructure that powers our daily lives. This migration has already begun.
So here's the key takeaway. We don't have to just sit around and wait for the quantum threat to show up at our doorstep. We can act right now. The future of security is hybrid. By embracing these kinds of protocols, we're not just solving a problem for tomorrow, for absolutely everyone, starting today.